In this video, we are going to continue to the last chemical terms that you have to master in order to finish your summative assessment. The last term will be LDL. This is my own terms, the LDL. Well, people usually use this term like, dissolve like. What does it mean? So basically, it is a very classical, classy. It's very old concept. Well, remember when you maybe were in primary school, you have, for example, oh, if I have, for example, water, you have water and you put oil in it. Now let's use different color. It's just to make it fancy. So for example, you have then oil, you mix them, then oil will not or will not be able to mix with water. Okay, so this phenomena now we can explain during like dissolve like situations. Let me give you one other example in here. If you have, for example, water again, water, and then you will have, for example, salt, they can actually mix. Okay, for example, if I give you what other example, yeah, maybe just these two example first. Okay, so the first one in here, oil is actually a non-polar molecule, and then water, as we discussed very many times in many situations, water is actually a polar molecules. Okay, so they both have different characteristic. Okay, so these make them, according to the theory of like dissolve like, the interaction will occur when two molecules have same characteristic are mixed. For example, this water and oil, they have different characteristic, so that's why there is no interaction in there is no interaction. They just live in different situation, in different nature, so that's why there is no mixing in there. Okay, so but the salt in here, in the second case, this is the first case, in the second case, salt is ionic bonding. Contoh salt is NaCl, of course is ionic bonding, and then water is polar. They have similar characteristic. Why? Because water, they have with water you will have partially positive and partially negative charge. Okay, this is partially negative, this is partially positive, this is partially positive. With NaCl, you have positive Na and negative Cl. There is the similarity of characteristic. They are charged, they are partially charged, they are positive and negative, so they will be able to interact. That's why salt will then dissolve in water. So there will be dissolve in water. When oil and water will not be dissolved, you say insoluble. Insoluble meaning they're not dissolved, something like that. They just completely separated. Okay, so that will be like dissolve like. So but then let's go let let me introduce you to soap. Okay, so there is the situation when we have both polar and non-polar situations, but we want to interact with both of them. I repeat again, there is the situation when we have both polar and non-polar characteristic of compound or molecule in one place, but we want to interact to both of them. So the situation, for example, if you have if you have, let me try my best to actually draw a like t-shirt or something. This is t-shirt or something like that. And then it has a, for example, I have it been wore for like 1 week. It needs laundry, so this is the dirty one. There is a lot of like blah 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 blah. There is dirt, maybe oil, and then yeah, other stuff. So basically, if you want to remove them, you the easiest way is you can give them oil and all of them will be dissolved and it will become clear. But then the oil, when you after you laundering it with oil, of course it's not gonna be comfortable for you to wearing it again. Right? So then the easiest or the closest, the most common compound for us is water to clean all the stuff. So but water is not able to interact with non-polar. In this case is the dirt and the oil. Okay, so well, water is not able to do that, but water usually is our best shot if we want to clean something. So then this what soap will come handy to you. Wait, so let's see the characteristic of soap in here. So it's a very long chain, and then suddenly there is this part COO minus. You don't need to like be overcomplicated with this. What you need to pay attention is, well, this side there is negative charge, and there is Na also, that's going to be positive charge. So this all line in here indicating the rest of the structure that you don't need to know for now. Oh, sorry. You just need to know that, oh yeah, there is a very long, sorry, there is very long structure in here. There are so many atoms in here that is not described, but what you need to know is there is no charge in there. So that's gonna be a no charge. That's gonna be indicating it's a non-polar. This one is not non-polar. We call it iron because it's just a definite charge negative. It's not partially charged. Now, this non-polar side, we call it hydrophobic group. What does it mean? Phobic mean afraid. Hydro mean water. So this is part when this part will hate water. Okay, this part will hate water, of course, because they're non-polar. Water is polar. So hydro in here mean water, so they don't like water. Why? Because they're non-polar. Water is polar. Well, in here they call it hydrophilic group. Of course, hydro still meaning water, and then philic in here mean like. So they like water. Why? Because water have charge, partially charged, and this part also have partially charged. So it means the soap can act into two different characteristic of molecule. So this is COOH. Again, you don't need to overcomplicate this. You just need to know, okay, there is that one and there is that one. So if there is water, you have water. For example, water is like this. Okay, this is water. How do you expect these two will interact? Okay, if you put soap in the water, what will happen is, for example, this is the molecule of water, something like that. So basically the okay, the COO will facing this part because this is positive, yeah, and this is the rest of the structure. Okay, and then because of course there is more than one soap molecule, right? in one. For example, if you have like one glass solution of soap, you don't expect them only have one molecule. There must be many molecule in there. So you're going to draw a lot of other soap in here. So this is the something like this, and this is the rest of the structure again. Okay, so this is gonna be um, something like that. This is from the water perspective. If you look at the soap perspective, what will happen is, well, they will hide. So this is the hydrophilic side, and then another hydrophilic side, for example, like that, another hydrophilic side. It just take time to draw all of these guys, so just bear with me. So you'll imagine this is gonna be like that, 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 and all of this is carbon, 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 and water will be. So this is the, for example, the whole molecules. Oops. Wait, just wait, bear with me. Okay, so this all will be like, okay, this is the negative, and then this is the positive. Okay, so this is the, and water will be in here. There is water, water, water will be in the outside of it. Okay, the one that will interact with water is the COO part. Okay, the COO part, the COO part, they all will interact with water. Why? Well, because they have similar characteristics. So that will be if you mix between water and um, soap. So as you can see in here, the non-polar part will be protected in here. They will not interact with water. They will be just in the center like that, and then the one that interact with water is actually the COO part. Now let's see if you use this soap to eliminate non-polar or oil, for example, in your dirty laundry. Okay, so uh, because of this ability, again, soap can interact with non-polar and polar at the same time. So imagine you have this dirt, okay, this dirt or this oil in your shirt. So this will interact with the non-polar side of the salt, so it's gonna be like this. Okay, so this is carbon, this is O minus, so this is again carbon, and this is O minus. You will have this and this and this and this and this. So this is carbon, 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 carbon. All of this has CO O minus like this. So and then water is in here. So as you can see now, the soap molecule basically able to lift the dirt, and then later on they can then mix with water. Now comparing to the previous situation, when you, for example, have water tadi and also oil in the same place, they will just be separated like this. Never ever the oil go inside the water. They will just separate it because there is no interaction in there. But by using this um, soap, this you can have in here the dirt. Let me change the color. The dirt like this, they actually have, they able to dissolve in water. So this is all of these, for example. So for example, take a look at this one. Wow, I'm so sorry, this is just too smart, but I don't expect that. So water now, I mean the dirt itself now can able to like go to the water by using this mechanism. Now the dirt can be able to surround it by water, so that will make later on easy for us to eliminate this. When we wash it, when we rinse it, then the dirt also will go away. That is the magic of soap. Okay, we're going to continue to part 2, bear with me. So like dissolve light will, there will be 2 part. See you in the part 2. Yeah.